What's up, everybody? Today is February 13th, 2025. Ready to do some Leetcode again for the daily. Not really sure how much the dailies are helping my contest rating, but gonna keep on keeping on and seeing how it goes. I might need to do more harder problems than the dailies have given us lately. So we're gonna go ahead and practice our typing speed. Not too bad. Couple typos, but pretty on spot. Kind of going down. Okay. Oh, excuse me for yawning. See what the problem of the day is. Product of the last k numbers. 1352, product of the last k numbers. Design an algorithm that accepts a stream of integers and retrieves the product of the last k integers of the stream. Retrieves the product of the last k integers. Okay. So it's a sort of like a size q thingy. Or a deck. Implement the product member class. Initialize object with an empty string. You can add a num. Appends the integer num to the stream. Get product returns the product of the last k numbers. The test case generates that at any time the product of any contiguous sequence of numbers will fit into a single 32 integer without overflowing. Okay. I'm thinking Q. So we're going to go with that. So let me explain what I'm doing. Sorry. Okay, so we have, I don't know, 1, 2, 3, 4, 5. Product numbers. What gives us the... Oh, get product of the... Oh, hold on. The last k values. Okay, Q's not going to work. Hold on. I didn't know K would change. Oh, wait. Any contiguous. Okay. This is going to be more like a prefix sum problem, I'm thinking. Right? So, in prefix sum, say if we had 1 plus 2 plus 3. Now, we'll talk about products in a second. 1 plus, or I'm sorry, we have the values 1, 2, 3, 4, 5. Okay? And at any time, we want to know the last k, the sum of the last k values, right? Well, if we had a prefix sum of 1 plus 2 plus 3 plus 4 plus 5, so a prefix sum of the whole thing, right? It would be 1, 3, 6, 10, 15, right? Well, say if we had, what if k was equal to 3? We want the last three values of the sum, right? All we would really need to do is take this value and subtract this value, 3, which would give us 12, right? So by doing this, okay, this would be 5 plus 4, which is 9 plus 3 is 12. Yeah. We should be able to do the same thing with the product, right? So if we have 1 times 2 times 3 times 4 times 5, if we do a a prefix product, I guess, it would be 1, 2, 6, 24, 110, I think. And say we want these last three values, we would just divide off 2, which I guess would be, if my math is right, that sounds weird. Hold on. 24 and 24 is 48. 48 and 48 is 96. I can't do basic sums, I guess. So this is going to be... Oh, no. 24. Oh, maybe this is 120, yeah. My bad. If we divide 120 by 2, we're going to get 60. If we do 5 times 4 is 20, times 3 is 60. Yeah, so we're going to do this sort of method for prefix, right? And now in order to do this, we're basically going to need a vector. It's going to be a vector of ints. We're going to call it product. And we're just going to, for add, we're literally just going to push it to the back. So we're going to go prod.pushback num. Oh, wait, I'm sorry. The product is going to be num times whatever's on the back right now, right? Like this. And if product.size, or no, size equals 0, which we can just say not, then we're just going to push back the num, right? So this will give us the prefix product. And then as far as getting this value back, we just want the kth value. I'm assuming that it should always work, right? Like, they're not going to give us a value we can't do. Return the product of the k. You can assume that always the current list has at least k numbers. Okay. So if we say k is equal to 3, we actually want the previous value. So there's going to be two situations. If k was prod.size, then we're just going to return the thing on the end. Prod like this. And if it doesn't, because we can assume that we always have at least k numbers, we're just going to divide it. So we're going to say return we want the last value, and then we're going to divide off the -1 of the k, or we're going to minus k values back -1. So the product.size -1. This is going to be the last value minus k, right? And this should give us the last value. Let's see if okay, division by 0. Nums can equal 0, huh? Didn't think of that. Okay, so if we have a 0, then everything is going to be 0. If prod.size -1 minus k equals 0, return 0. So we have a 0 here. Oh, I see. If you go this many back, you'll get a 0, right? So we need to keep track of the number of zeros. And anytime 0 goes far enough back, we have to say, okay, it's 0. Okay. So we need to keep track of zeros. But how do we do it in such a way that a given k value Oh, hold on. I have an idea. So this will give either the previous value for 0 or a -1. Okay, so here's my idea. Let's go ahead and take this as an example. So we have 3, 0, 2, 5, 4, 2, 3, 4, 8, 2. Okay, and we're doing the product, right? So normally in the products, we want to just keep multiplying the products, right? For the product sum or product prefix product, right? But if we ever get a 0, then it zeroes out all the products. So what we're going to do is every time we find a 0, it's going to reset the product, right? So I'm just going to say, instead of this, I'm just going to set this to a 1 and have my product array. So for instance here, this is what we're going to do. It's going to say 3. This is going to be 1, 2, 10, 40, 80, 140. Just get awesome values, right? Okay, so we have these values. But then in my other array, we're going to have 0. This is an index 1, 1, 1, 1, 1, 1. So if we want to go k back, right? Say if we go k back 3, or 3 values, right? Then we're going to say this index, or if this index encompasses the 1 index. So, for instance, if we went way back here to index 1, then you know this is 0 and this is zeroed out. However, if you go back here and the index is greater than that, then it's not. So I think that's what I want to do, right? So we're going to go here. Okay. If there's nothing in there, then we're going to say if num does not equal 0, then prod dot push back -1. Or no, 1. Wait, no. If num does not equal 0, then we want to push back. Oh, this is the first one, right? Yeah, it would need to be -1. Okay. Else, if num equals 0, then prod.push back 0. Now, this is only true, or I'm not, oh, this is 0. This is only true if there's nothing in the product, right? Okay, so if num does not equal 0, we want to push back the value wait, if prod.size okay. So if the num does not equal 0, do this. Else, the num is equal to 0. Then we want to just push back 1, right? Okay. Okay, if k is equal to the prod.size, so if it's the whole thing, hold on, let me think. If 0 dot size, so if 0 if the last thing, does not equal -1, return 0. So if we're using the entire array and the first value is 0, go ahead and just return 0. Okay. Otherwise, return the last product. Okay. Now we're going to say else. If it's anything else besides the whole value, this isn't going to work. What really is going to work is saying we need to go k minus 1 back. Wait, no. Hold on. Is that going to work? We want to check both the start and the end, because there might be a 0 inside of the value, right? No. Hold on. This is 1. If we go k back, say we're index whatever, as long as this index is greater than this value, here, then we're good, right? So yeah, because it's keeping track of that. So 0 dot size minus 1. If this value k back, right? So k back from here give me a second to think about this. If we go k back, so say 3, it would be product dot size. Oh wait, no. Yeah, it's this. Right, this. So if this value here is less than, right? So if we say 3 back here, well, it's never going to be greater than or equal, right? Wait, hold on. Not k. If the last value I'm sorry, if this value because we're doing the product. Okay. Hold on. I'm thinking about this wrong. 2040. Hold on. 13. Get product. 32. Add 2. Get product 0. 0 is here. Oh, I see. Hold on. Get product 2. 2 back. Add 8. Get product 4. Get product 3. Get product 2. So these are our values. 1, 2, 3, 4, 5. So 30254. Okay. 4 back. We're at index 1. Let me think. Oh, hold on. Yeah, because I didn't finish my zeroing vector. Okay, there we go. Okay, well, that's my idea. Let's see if this works. Did not work. Okay, something must be wrong with this. 1, 2, 3, 4, 5. One, 2, 3, 4, 5. Okay, we have double zeros. And then we have a get product. And then another add. Get product. And add another 3. Okay. Our products are going to be 3, 1, 1, 8, 24. $168. 504. Okay. And then our 0 is going to be 0. 1, 2, 2, 2, 2, 2. Okay. So we're asking for 5 back. We have up to 7, so 1, 2, 3, 4, 5. Okay, we have index 1. Or no. 5 back translates to 1. 1 is less than 2. Okay. One. Is this supposed to be the other way around? No. Hold on. Let's see out our 0 first. Oh, we need to use this. Well, there's part of our problem. Let's see. If num does not equal 0, -1, else 0. Okay. Num. Wait, hold on. Else if num does not equal 0. So there's something in there. Num does not equal 0. 0 equals the last thing, which would be -1. Right. So -1. Okay, else. Again, this is my fault. Back. Whatever the last index is, right? So it would be 1 here, right? Which is why this was working originally. Which means this is probably backwards now. And this looks like it's 1 off. Hold on. This one works. -1, 1, 2, 2. Yeah, that's good. And this is good. Okay, so the 0 is good. Now it's the math behind the 0 that's wrong. Let's see. Okay, so 40. Three. Oh no, 1 times 2 is 10 is 40. One, two, three, 4, 3. Here. 0.size minus k. Yeah, I think that my math was just off. Okay, let's go ahead and try to submit this. We're still off. Okay, so in every case, we add 0. Division by 0. Hold on. So the last value is -1. That means there's not a single 0 in the whole thing. Okay, so if this, we want to return this. Because there's no zeros. Yeah. Otherwise, there was a 0 in the beginning. Ooh. Okay, well, there you have it. Just keep 2 arrays and you're good to go. Alright guys, that was the daily problem. Thank you for joining me. I hope you all have a wonderful day. Peace.